This is a continuation for the previous discussion. So we are still on moments of inertia, the first part of the moments of inertia. But this discussion is part 3 of this first part of moments of inertia. So the first part of the moments of inertia talks about the second moment of area, because the second part talks about the mass moment of inertia. This is this is a long discussion, so moabot gid siya og kanang kuano tulo ka kanang meetingan. So we are now on lesson 2, moments of inertia for composite areas. From the previous discussion, from the previous recorded videos, I hope nga inyo na to nakita. We discussed only the moments of inertia for a single 2D figure or 2D plane. But in reality, of course, most objects that we've seen are composed of 2 or more figures. So in this lesson, we are going to solve its moments of inertia. So by the end of this lesson, you will be able to apply the principles of moments of inertia in determining the total moments of inertia for composite figures. Now, for a composite figures, the rule is when a composite area can be divided into geometric elements for which the moments of inertia are known, the moment of inertia is just the sum of the moments of inertia for the separate elements. So, sum lang of the moments of inertia. Let's say, for example, we're going to derive the generalized formula for composite figures. If we have here an xy plane, and then on this plane we have several objects or figures, simple figures. Let's say we have here a rectangle, and then we have a triangle, and then we have a circle. Of course, these 3 figures have an area. Let's say this one, we have the area of the rectangle, AR. We have area of the triangle, AT. And then we also have the area of a circle. Now, these 3 are obviously separated by each other. But my point here is to show you how to combine their moments of inertia with respect to a certain axis. Let's say we're going to choose the abscissa as our axis or the x-axis. So these 3 objects will tend to rotate along this axis. So what would be the the total or the resulting moments of inertia? So of course, the rectangle has its centroid located at the middle of its area. So ato na siya kuanan as YR. Of course, the same thing with the triangle. Ang location sa centroid is 1/3 of its height, with respect to the base. So we also have here YT. And then of course the circle, YC. So the total moments of inertia, IT, is just the sum of the individual moments of inertia. So we have for the rectangle, so we have YR, don't forget, naka-square na siya, times the area of the rectangle, plus we have YT square, area of the triangle, plus we have YC square, area of the circle. Again, don't forget that these 3 distances, YR, YT, and YC, dili na siya ingon nga distance from the base lang, from the base towards the axis, from the base of the triangle towards the axis, or at the bottom part of the circle towards the x-axis. So always remember that this distance starts from the centroid of the object towards the axis. Okay, be mindful with that one. Of course, if we're going to apply this principle on a real composite figure, now let's say this is y and this is x. So again, kuanday i-note that this total moments of inertia is only limited along the x-axis. Okay, because of course, if we change our axis, let's say, how about if we're going to determine the moments of inertia along the y-axis, it's a different thing. So here, let's try another composite figure that are kanang or that are compact, no? So let's say we have here a rectangle, tapos there's a triangle. Okay. So kani siya nga figure are comprises of two simpler figures. We have the rectangle on the left and we have the triangle on the right. So in order to know the total moment of inertia of this composite figure along a given axis, let's say x-axis lang sa ta, no? So the same ra gihapon. First is I should be able to determine the area of these simple figures. Let's say on the left we have the area of the rectangle, on the right we have the area of the triangle, and see to it that you can determine the distance of each of these figures, no, from the x-axis. Okay, so this is yr, and kailangan you must also know how to define its centroid, and this is yt. So the same thing, the moments of inertia of this composite figure with respect to the x-axis. So itx stands for the total moment of inertia along the x-axis, is equal to the sum of these individual figures. So we have again yr, don't forget, naka-square, times the area of the rectangle, plus we have yt, square area of the triangle. Okay, same lang. Now, we have the third illustration. What if a composite figure, no, na siya yung mga holes or na ay mga cuts. So ang atong buhaton, let's say for example, if we have here a rectangular figure and then there's a circle, no, at the center, so meaning ang na-covered lang kay kanilang ang moment of inertia lang of this shaded portion. So to know its total moment of inertia with respect to a certain axis, of course, the same thing what we did in finding the centroid, no? Nag-introduce mo ta dito og kanang subtraction. So with the moments of inertia, we can also use the subtraction rule, because we can solve this composite by dividing this one into two parts. We have the rectangle subtracted by a circle. So let's say our axis of rotation is along the x-axis. So the total moment of inertia for this composite figure is just equal to, first is the rectangle. So we have the area of the rectangle, and then we also have the area of the circle, and of course yung rectangle natin from its centroid, it has a distance yr, and of course our circle meron ding centroid, it has a distance of yc. So our total moment of inertia, so that is the moment of inertia of the rectangle along x minus moment of inertia of a circle along x. So for the rectangle, that is yr squared, area of the rectangle, minus yc squared, area of the rectangle. Okay? So, naipangutan na? Nasabtan na? Nasabtan ang concept? So, let's have our 7th example. So, we have here, problem, find the moment of inertia daw about the indicated x-axis for the shaded area as shown. So, along this axis kani. First things first is we need to break down this composite area into simpler figures. So, diri as the solution, first is kani siya composite figure, pwede ni siya mahimo og first is we have the rectangle gid, no? We have the rectangle plus we have a semicircle, di ba? Natay semicircle at the upper base of our rectangle. So we have, okay, it's not plus but minus sign because the resulting composite area, no, is subtracted by this semicircle at the top. So minus the semicircle at the top. Of course, kailangan maintain ang ato ang axis. Okay, naapod lang ang atong axis. Okay. So that is equal to our composite figure. So ano na siya? Okay. And of course, this is again our axis. So if we're going to interpret this one, so we can say that the moment of inertia of our rectangle along the x-axis subtracted by the moment of inertia of this semicircle, so atola i-note as SCX, is equal to the moment of inertia of this composite figure along the x-axis. Okay, so from here, we're going to start our analysis sa rectangle. So first, for the rectangle, I hope nga nag-take down notes mo dira. So for the rectangle, we're going to do a rectangle. Okay, so this is the x-axis, no? And of course, the center of a rectangle is obviously at the center part. So ato lang butangan og axis. This is the centroidal axis, ato i-denote as O. And then distance of this centroidal axis with respect to the lower axis, the x-axis, is of course half of its height, h over 2. Because this one right here is the height of the rectangle, and then this one is the base, no, or the width of the rectangle. So in order to find the moments of inertia of this rectangle along the x-axis, so we're going to use the parallel axis theorem. Now if you watch the previous video, then maka-gets mo ni ani. So the moments of inertia, no, of this rectangle with respect to the x-axis. So why I highlighted this one, it's because the moments of inertia of this rectangle along the centroidal axis and the moments of inertia of this rectangle along this x-axis are different. So lahi. Okay, again, ang moments of inertia mag-differ siya at any given axis. So magana yung inumduman. So since sa previous nga video, we already know or nakaderive lang ta sa moments of inertia of the rectangle along the centroidal axis, no? So mura na itong nahibawan. So therefore, we need to use the parallel axis theorem. So the parallel axis theorem states that the moment of inertia of the object from any axis. So ang lahi nga axis dira is the x-axis is equal to the moment of inertia of this object. So our object is the rectangle. Now the moment of inertia along the centroidal axis. So O plus the area of this object. So area of the rectangle times the square of its distance. So on something distance. So the distance here is defined as the distance of these two axes. So our reference axis is the centroidal axis, and then ang axis of interest is the x-axis. So the distance between these two axes is defined as the d, and we're going to take the square of this distance. So a d square. This is the formula for the transfer of axis, or it is also known as the parallel axis theorem. So always keep in mind that the other axis, no? So our axis of interest here is the x-axis. Make sure that this axis, no, should be parallel to the centroidal axis. Dili pwede nga mag-slant na siya or mag-intersect. Dili na siya pwede. Dili na siya mo conform sa ato ang parallel axis theorem. Remember by one of its word, no, parallel. So kailangan parallel ang duha ka axis. So diri mao ni atong ipangita the moment of inertia of this rectangle along the x-axis. So on the previous discussion, we already know the moments of inertia of this rectangle along its centroidal axis. So our IRO is equal to BH cube all over 12. Okay. So ato na siya i-plug in diri So we have BH cube all over 12 plus, what is the area of a rectangle, class? Okay, so we have base times height, and then the distance, no, of these two axes. So we have half of the height. So height over 2 square. Next, ato na siya i-simplify. So we have BH cube all over 12 plus we have BH cube. This is all over 4. Now, if we're going to combine this one, no, because they have the same numerator, BH cube. So we have BH cube times 1 over 12 plus 1/4. The resulting fraction is equal to 1/3. So therefore, the moments of inertia of a rectangle along the x-axis or along its base is just equal to BH cube all over 3. So since we have a value for our base and the height, our base is equal to 8, no? Our base is equal to 8 inches, not 4 inches because the 4 is half of the base, and the height is equal to 10 inches. So substituting the values, we have 8 times 10 to the power of 3 all over 3. So the answer is, we're going to use our calculator. So we have 8 times 10 shift divided by 3. So the answer is 266.66667. So ato lang round off, we have 2666.67 inch. Don't forget to the fourth power gida basta moment of inertia. Okay. So we're done with the moments of inertia of the rectangle. Next is the moments of inertia for our semicircle. Walay pangutaan ani nga part. Class, walay question ani? Okay, hearing none. So proceed ta sa semicircle. Kaduha, semicircle. So for the semicircle again, nasa sa topmost, no? Nasa sa babaw. And then the axis is only at the bottom. So this is the x-axis. And of course, our semicircle has a centroid. So naadri dapita ya centroid. The centroid is not half of the radius. So di na siya equal to half of the radius. Na siya lahi ng value. And we already solved for the centroid of a circle or a semicircle. I hope that you still remember that one. So we all know that the distance of the topmost part of our semicircle, no, from the x-axis is equal to the height. Okay. And then the distance of its centroid, no, from the centroid to the x-axis, or meaning the distance from these two axes, ato lang siya i-note as y, or d na lang, d. Okay. And the distance from the topmost part of our of our centroid, our semicircle. So this is y c bar. So sir, unsa man ang y c bar? This is the centroid of the semicircle. Paubos lang siya. Okay. So here, we're going to use the parallel axis theorem because ang atong axis of interest is different from the reference axis. Our reference axis here is the centroidal axis, that is the axis labeled as O. So from the parallel axis theorem, so we have I, the moment of inertia of our semicircle, as C along the x-axis is equal to the moment of inertia of this semicircle along the centroid plus the area of this semicircle times the square of the distance from these two axes. Now, unsa may moment of inertia, no? Unsa kay moment of inertia of this semicircle along the centroid, no? Unsa kaha? Now, we have a generic formula for this one, no? In some books, the moment of inertia of this semicircle along the centroid is equal to 0.11 r to the fourth. So, asan po na siya gikan? We can derive that one, no? By focusing on the semicircle alone. Say, for example, we have here a semicircle, no? Kung ma-memorize nimo na siyang moment of inertia of the semicircle along the centroid nga 0.11 r4, mas mayo, pero mas mayo sad if you know the derivation. So let's say this is our semicircle. The base of our semicircle, ato na siya i-labeled as xx. Again, this is different from our figure right here. In this figure, I will just let you know the derivation of this one, kung asa nagikan ng 0.11 r to the fourth. So again, the axis that passes through the centroid of the semicircle is again still O, and we all know that this distance is the centroidal distance, yc bar. Now, in order for us to determine the moments of inertia, no? The moments of inertia along the centroid, because mamo na ato ang gipangita, we're going to use the parallel axis theorem again, no? So, kay man ta that I xx is equal to IO, no? Minus the area of this semicircle times the centroidal axis square. So, the same ra sila og porma sa atong mga parallel axis theorem. Okay? Okay, this is not minus, this is plus. Okay, this is addition. So, diri nag-after ata aning IO, the centroidal axis. Okay, kani. Ato lang ilisan ang pag-represent para di maglibog. So, this is semicircle manita. We're talking about semicircle. So, I semicircle O. Okay. Kay bawta sa kaning IXX because the IXX is the moment of inertia of a semicircle along the diametral axis. I hope nakasunod mo ato. It's because the IXX, no, is equal to pi r to the 4 all over 8. Okay? So, sir, asan pa nagikan? So, we all know that the moment of inertia of a circle along any diametral axis is equal to pi r to the 4 all over 4. Now, asa man nagikan, sir, kaning IXX, or this is the moment of inertia of a semicircle along its base. This is just one half of the circle, diba? A circle is a whole, whereas a semicircle is half of the circle. So if we're going to multiply this one by 1/2, the resulting is pi r4 over 8. I hope na gets ra. So with this, what else? Ang kuwang is the centroid. So yc bar is equal, this is equal to 4r over 3 pi. We already derived this one from our discussion about centroid. So with this, we can solve for ISCO. Okay? So diri alang nato ibutang. So we have here ISCO is equal to, so ato lang ni i-rearrange ang ato formula. So that is IXX minus the area of our semicircle times YC bar square. So again, our IXX, this is pi r to the 4th all over 8 minus the area of a semicircle is half of the area of the circle, so pi r squared divided by 2. And then this is 4r over 3 pi. And that is square. Now, if we're going to combine this, no? If we're going to simplify this further, no? We have pi r to the 4th all over 8 minus. So this is pi, tapos ang 4 dira ma square, no? So we have 4 square. Tapos ang sabos 2 times 3 pi square. Then I'll combine the r square and the r squared pag diri. So r to the 4th na siya. So combining the constants, no? We have I SCO is equal. So maggamit ta og calculator ni ani nganong nahimo na og 0.11. So in our calculator, press AC. So kani siya, okay, sorry. We have first term pi all over 8 minus the second term is we have shift pi times 4 squared all over 2 times 3 shift pi squared. So ang result is 0.1097 or approximately 0.11 r to the 4th. So that is our moments of inertia of our semicircle along the centroidal axis. So going back to our equation, this one right here. So we have, okay, let me isolate this one. So we have ISCX is equal to ISCO, so that is 0.11 r to the fourth plus the area of the semicircle daw, so that is half of the area of the circle times the distance. Again, d here is the difference of the height h, no, h minus yc bar, okay, yc bar square. Simplifying further, 0.11 r to the fourth plus pi r squared over 2 times height minus, we all know that yc bar, this is the centroid, that is equal to 4r over 3 pi. So we have 4r over 3 pi, that is square. Next, substituting values. So dali lang, we have ISC x is equals to 0.11. Our radius is 4 inches, no? So we have 4 raised to the fourth plus pi 4 square divided by 2 times the height is 10 inches, no? 10 minus, we have 4 times 4 over 3 pi, and then we're going to square that one. So our moment of inertia of our semicircle along the x-axis, so ato i-compute, we have 0.11. Our radius is 4 raised to the fourth power plus the area of our semicircle, so pi r squared divided by 2 kay semicircle man, times the height 10 minus the centroid, so 4r, so 4 times 4 over 3 shift pi, then take the square. So the answer is 1760.53. So approximately 1760.53. That is inch to the fourth. Okay? So mao na siya ato ang value for the moments of inertia of our semicircle along the x-axis. So naay pangutana ani? Okay, wala. Wala ra. So sa next slide, ato na i-sum up, no? Ato na i-perform to ato ang kani siya, kani nga formula. So kani, ito rin ang gamiton. So we have, therefore, we have I, the composite along the x-axis is IR along the x minus I, the semicircle along the x. So starting with the rectangle along the x, so from the previous slides, we have 266.67. So we have 266.67 minus the semicircle. So we have here 1760.53. So 1760.53. So if ato na siya i-subtract, so we have 266.67 minus 1760.53. So our final answer is approximately 906.14. So 906.14 inch to the fourth. So this is our moment of inertia of the given composite figure along its base or along the x-axis. Okay, so what na pangutana? So let's proceed sa final na tong problem. Still a composite figure. So the problem, compute the moment of inertia of a 10-inch by 15-inch rectangle as shown about the axis to which it is inclined at an angle theta equals inverse sine of 4/5. So the inverse sine of 4/5. Ang hint ani, i-resolve daw ang figure into parts A, B, and C. So again, this figure will tend to rotate along this given axis labeled as X. So ang technique ani, gihatag naman, no? I-resolve daw ang figure. I-break down into into three parts. We have parts A, B, and C. To interpret this one is we're going to add these three moments, no? Because the part A, of course, it will add the moment, no? So napo siya moment along the x-axis, and the same thing with B and C. So ang imong pag-illustrate ani, you can start with the object B. Okay, so si object B mo ni ang ato ang axis. So of course, we can label that this parallelogram, because this is a parallelogram, it has a base B, and ato la ilet that it has a height of h1. So ato i-add, no, plus the moment of inertia of the upper triangle. So upper triangle, paana siya? Okay, so again, this ang iya base kay B gihapon, the same thing with the parallelogram, and this is the x-axis. Plus pagyud, this triangle di ay ato pud i-solve iyang height. So h2 lang ni siya. Okay, so plus na pod, plus the moment of inertia of the lower triangle. So if this is our x-axis, ang lower triangle lagi nga na siya. Okay, so this is B, this is A, and this is C. Remember, this is a right triangle. Okay, this is a right triangle. So our C still has a base of B. The same thing with the base of our parallelogram. And then, of course, it has a height, no? H2. So the same thing with the upper triangle, because if imo na siya kitaon, the triangles A and C are equal, no? Are equal to each other. We can also prove that one the later. So diri that is again equal to our final object. So our final object, paana siya? Okay, this is our final object. So yan na, the composite. Okay, so with this kanin siya nga illustration, we can say that the moment of inertia of our object B along the x-axis plus the moment of inertia of A along the x-axis plus the moment of inertia of C along the x-axis is equal to the moment of inertia of this composite object along the x-axis. Basig ang uban dira nagwonder, no? Wala day mga negative nga moments, sir. Let's say for example, dili day ingon nga if ang area kay located below the axis, di siya mo take sa negative nga sign. So for the moments of inertia class, walay negative, walay positive. Okay? So even if below siya sa axis, even if above the axis, so take gihapon siya sa positive nga sign. Okay? Kaya nga to ani is its tendency to rotate. Unlike for the torque, no? Unlike for the torque has a sign convention. So if that is counterclockwise, it could be either positive or negative, depende sa mong giset. If the direction of rotation is opposite, so that is now the time that um, you can say that it is negative or it takes the negative sign. But for the moments of inertia, so wala nga na, all are positive with respect to a given axis. Naay topic for moments of inertia nga naay sign convention, and that is the product moment. Okay? Product moment of inertia. So, lahi na po na siya. Diri sa to moments of inertia lang. So, all are positive. Now with this, again, start na punta for the parallelogram, but let's have the kuan muna, no? We're going to solve sa kaning mga variables nga ato ang gipang initialize diri So we're going to solve for, first is the height 1. This is very important in solving for the moments of inertia of the parallelogram, or simply we can also assume this as a rectangle, no? Height 1, and then we also have the height 2. This is for the triangle, for the two triangles. And then the last one is the base B. Okay. So, sir, mugana di ang formula for the parallelogram. Mugana di ang formula for the rectangle sa parallelogram. Yes, mugana siya. It's because the formula for our rectangle is just base times the height. So, wala mo siya naingon nga base times the side. So, si parallelogram has a base and has a height, a known height. If the given is the slant height, so you need to solve, no? You need to solve muna the height of this parallelogram. Again, height or altitude. So height is different from the slant height. So take note with that. So here we are going to use geometry and trigonometry. So if we're going to illustrate again the figure, so this is the figure. Pana siya. Okay. This one, ato siya i-project now. So paana. And then this one measures 15 degrees. So this is 15 degrees. I mean 15 degrees, 15 inches. Sorry. And then based on the illustration, this angle right here is angle theta, and understood that this angle right here is also the same theta. And then this angle, no, this angle is not theta because the only theta here is this one, kaning below, no? Theta na siya. Remember sa trigonometry. Now, since the corners of this rectangle is 90 degrees, so we can say that this theta is, this angle is 90 minus theta. Okay. Useful na unya. Now, the ang measurement from the tip of this rectangle towards the x-axis is the sum of height 1 plus height 2. Okay? Because the upper portion of this rectangle with respect to the x-axis is we have the height of the parallelogram B and the height of the rectangle A. So for parallelogram, that is H1. For the upper triangle, that is H2. So manang i-add na siya. Now, we can also project, no? We can also project a vertical line from the topmost corner of this rectangle towards the x-axis. Now, if we're going to extract this triangle, we can create this geometric shape. So this is a perfect right triangle, and of course natay theta, and again take note that this height is h1 plus h2, and the length of this one is 15 inches. So with this, we can solve for the height 1 and height 2, no? So diri we have, again, let's complete this figure. So h1 and h2 are opposite sa angle, and we have a given hypotenuse, so we can use the sine relation. So we have sine theta is equal to h1 plus h2 all over 15. Now, from the given, theta daw is the inverse of 4/5. So therefore, it is understood that sine of this theta is equal to 4/5. Okay, gibalira. So we have here 4/5 equals h1 plus h2 all over 15. Now, ato siya i-multiply, cross-multiply. So we have h1 plus h2 is equal to 4/5 times 15, and that is equal to 12. Okay, so we have now an equation, h1 plus h2 equals 12. So this is our first equation. So we need another equation, no? So that we can solve for the height 1 and the height 2. So walay pangutana ni sa ato ang first slide for example number 8. Walay pangutana? Lara. So next lahi na pud nga kung ano nga figure ato ay i-draw. So sa upper part, balik ta diri sa upper part, we have the triangle. Now let's focus on that upper part so that we can solve or we can come up another equation that contains at least the height 1 or the height 2. So that if we have that equation, then we can pair that one sa ato ang equation nga nakuha diri that we have just derived. Okay? So on the upper part, we have the triangle A. So mao na siya. We have the triangle A. Okay? So this one, this is a right triangle. And from the previous illustration, we have 90 minus theta. So this angle is 90 minus theta. Okay. And we already know that this one, ato na siya labeled as B, or the base of the triangle, and at the same time, the base of our parallelogram B. So this one again, ato na siya labeled as height 2. Okay. And this one, okay, this one is theta. Okay. So we can also project that one, no? Pwede po natin siya ma-project dira. Okay. This one, so may sukod ani. So this is given. That is equal to 10 inches. So this is 10 inches. Okay. And then we can also let this one as side C. Ato na siya magamit unya. Again, ang goal nato diriya is at least we can derive an equation that contains either h1 or h2. Okay, para makuha nato sila because we only need one equation, no, in order to solve for h1 and h2. So in this triangle class, if ato i-extract lang ang kani nga triangle, kanilang, no, 90 minus theta. So this one is 10. Okay, and this one, can you see the altitude is equal to h over 2. Okay, so therefore makakuha din ta, no, we can use the sine relation. We have sine 90 minus theta is equal to the opposite, so that is height 2 over 10. Now sine 90 minus theta, that is equal to cosine theta, pero giun sa man, So ato lang ni i-derive further, no, especially sa uban nga nakalimot sa derivation. So are you familiar with sin, cos, cosine, cos, cosine, sin? Class, naba mo ana sa inyo trigo? Kanang, naa, di ba? Kalimot na? Sin A minus B. Right? This is sin A cosine B minus cosine A sin B. So, ato lang i-review dre, basi nakalimot na. So, we're going to use this identity or relation. So, we have sin 90 cosine theta minus cosine 90 sine of theta equal to h2 over 10. So sine 90 is 1. So what's left on the first term is cosine theta. However, for cosine 90, this is 0. So makancel ang second term. So we only left with cosine of theta is equal to h2 all over 10. With this, we can solve for h2. Okay? We can solve for h2. Wherein h2 is equal to 10 cosine of theta. But sa ato nga given, theta daw is arcsine of 4/5. So 10 cosine of arcsine, no? Arcsine of 4/5. Okay. So ato gamitan og calculator. So sa ato calcu, press AC 10. See to it that your calculator must be in degree mode, no, so that will arrive a nice answer. So shift mode, press degree, tapos you're now ready to solve this one. So 10 cosine, shift sine, so that mark sine siya, tapos 4/5. Okay, because again the output of this one is in degrees, no? Unya kung naka-radian na, sayop na daan, so degree dapat. Okay, that is equal to 6. So height 2 is equal to 6 inches. Now, from equation 1, no? From equation 1, we all know that, okay, sa ato nakuha, height 1 plus height 2 equals 12. So h1 plus h2 equals to 12. So therefore, our height 1 is equal to 12 minus height 2, or simply height 1 is equal to 12 minus 6, which is equal to 6 inches. So ato na na-prove that the height no, the height of this parallelogram is equal sa height pod ani nga triangle. Okay? Same rin sila kay 6 inches ning duha. Okay? So for the next slide, we are going to solve for the base B. Okay? Kay if we're going back to the first, no? I mean sa previous na slide kani, height 1 check, height 2 check, but wala pa tay B. Okay, wala pa tay B. So diri ito sa next slide, still the same triangle, no? Sa upper part. Okay, sa upper part lang. Balik ta sa upper part. So this is again, this is 90 minus theta. Then this is the base B. Okay, and then this one measures 10 inches. Okay, and then of course we can project a vertical line, and kaganiha atong gilabeled na as C. Okay, now if ato na siya i-extract, okay, I forgot, this is theta. If we're going to extract this small triangle, so ato siya is extract. Okay, ana, so this is C, and this is H2. Okay, and ato na na-solve, that is equal to 6 inches, and this is theta. Now, makasolve na ta for C. Okay? Makasolve na ta for C, or naay usa ka way, no, nga without utilizing C, no, kay if isolve pa nato si C, then solve na pod for B, duha ka steps, but imo kitaon, no, as you can observe sa ato nga triangle, daghang kay given, ato lang ipang isolate gamay, no, inyo mapansin, this is a right triangle, this is theta, no, this is theta, this is the base, no, this is the base, and mo ni siya ang sukod ani. Okay, now base is the hypotenuse of this right triangle, and 10 is the opposite side. So therefore, we can take sine theta, di ba? Makatake ta og sine theta. So we have sine of theta is equal, the opposite side of this angle theta is 10, no? All over the hypotenuse B. So therefore, our B is equal to 10 over sine of theta. That is 10 all over 4/5, diba? 4/5. Okay? Sa may answer ani. So 10 over 4/5. So we have 12.5. So 12.5 inches. So nanatay height 1, nanatay height 2, nanaputay base B. Now next, we're now ready to solve for the individual moments of inertia of these three parts. So let's start with the parallelogram, no? Parallelogram. Parallelogram B. Now sa atong parallelogram, again, this is our x-axis. Then mo na siya atong parallelogram. This one right here. Okay. So our parallelogram has a height h1. This is 6 inches. And then napo siya base B, which is equal to 12.5, no, 12.5. Okay, 12.5. And then of course the centroid of this one, no, yeah, centroid is half of the height, so h1 divided by 2. Okay, so this one, using parallel axis theorem, no, so we have ix of this parallelogram B is equal to the IO, or the moment of inertia along the centroid B, no, plus the area of this parallelogram times height 1 over 2 square. So again, for a triangle, for a rectangle, we have BH1 cube all over 12 plus BH1 times H1 all over 2 square. So if ato na siya combine, the result is BH1 cube all over 3. So ato ipang substitute ang values, our B is 12.5, tapos our height is 6 cube divided by 3. So if we're going to solve this one, the answer is 900. So inch to the fourth. Okay, this is for the parallelogram. So nakasunod ra? Nakafollow? Okay. So next, number 2, we have the upper triangle. Okay, upper triangle A. So for the upper triangle, what should I draw? Okay, this one. Then the location of its centroid right here, and this is the axis, no? Axis X. Now, we already know the distance of this one. This is height 1, diba? This is height 1. Kani siya kani. We already solved this one, which is also the height of the parallelogram. Now, this one, kaning gikan centroid, this height here is equal to 1/3 of the height of the triangle. So therefore, uh, the total distance, no, d is equal to height 1 plus 1/3 of the height 2. So applying parallel axis theorem, so we have Ix of this triangle A is equal to the IOA plus the area of the triangle A times the square of its distance, so h1 plus 1/3 h2 tapos square. So we all know that the centroidal moment of inertia for a triangle is bh cube, no, bh2 cube all over 36 plus the area of the triangle is 1/2 base times its height, no, times h1 plus 1/3 of h2 and then square na siya. So diri ato siya ipang kung ano plug in ang mga values. So our base is 12.5 inches, then our height 2 is equals to 6 inches. The same thing with the height 1. So we have here 12.5, height 2 is 6 cube all over 36 plus 1/2. The base is 12.5. Tapos height 2 is 6 multiplied by height 1. We have 6 plus 1/3 of the height 2, 6, and then squared. So if you're going to solve this, no, the result is 2475 inch to the fourth. Okay, so mo na siya nga to ang moment of inertia for the upper triangle. So for the last, no, for the last we have the lower triangle. Okay, lower triangle C. So for the lower triangle, again, this is our x-axis. Then this is the lower triangle C. So mo na siya ang iyahang location of its centroid, no, and of course natay distance, and then this is its base, and then napod siya height 2. Okay, so by parallel axis theorem, I mean diri the distance is again 1/3 of its height, so 1/3 h2. So again we have the moment of inertia xc is equal to the moment of inertia of this triangle along its centroid, no, plus its area times the square of its distance. The square of its distance, the d is just 1/3 of its height, no, square. So again, for a triangle, don't forget its centroidal moment is base multiplied by its height cube, and that is 36, plus its area, that is 1/2 base times h2 times 1/3 h2 square. So substituting, our base again is 12.5 inches. Our height 2 is equals to 6 inches. So 12.5 times 6 cube all over 36 plus 1 half. Tapos base is 12.5 times 6 times 1/3. Our height is 6. Tapos square. So if you're going to solve this, the result is 2 to 5 inch to the fourth. So this is the moment of inertia of the lower triangle. So walay pang tanan eh. Walay, walay pang tanan class. Okay, hearing none. Wala na. So, dili lang na tayo isuwat, no? So, ang last step is to sum up this moment of inertias. So, we have Ix. The total is Ix ace, ang upper triangle, plus the parallelogram, plus the lower triangle. So, for the upper, we have 2475 plus the parallelogram, we have the 900 plus this one, so we have 2 to 5 inch to the fourth. So if you're going to add this, the result is 3600 inch to the fourth. Okay, so this is our final answer. And that's it for our moments of inertia nga discussion.